do today is pretty much take what we've been doing, but now the difference is that this is the general antiderivative, which means that we are going to find the function that comes before the function we're looking at in general, meaning we are not finding it at a particular interval. So we had an A to a B where A was equal to a number, B was equal to a number. We found the area under a curve from point A to point B, and we got a definitive numerical answer. Now we're going to pretend that we want to find this function that could live anywhere in the universe over any particular bounds. So suppose we want to find f of x dx, whose derivative is 3x squared. What would it be? So antiderivative says you add a power, divide by the new power, right? So if you know that capital F of x represents the function that came first, then f of x is kind of like f prime of capital F of x. So the function that will come before it is f of x equals x cubed. The problem with that is that technically that's not the only valid answer. Because in derivative form, if you take the derivative of a constant, the derivative of a constant is 0. So I could technically tack on any value being added or subtracted to this, and I would still end up with that derivative. So you could technically make capital F of x x cubed minus 1. You could make capital F of x x cubed plus 2. Like, there are an infinite number of actual choices that could follow capital F of x 212. Like, there are an infinite number. So what we say is what we're going to learn today, that the antiderivative of a derivative is going to be equal to that antiderivative plus some constant arbitrary number c. So, like I said, it turns out that there are an infinite number of answer choices that could technically be the antiderivative of 3x squared, because any of the following functions with an added or subtracted constant would make it true. The list will go on and on and on and on. So what we do to account for all of those infinite number of choices is say that capital F of x is equal to x cubed plus some arbitrary constant c. So we're going to antiderive today exactly like we know how to antiderive, but instead of plugging in a number for an upper bound and a number for a lower bound, we're going to antiderive and add on a plus c. So instead of saying what function would have a derivative of f of x, we also write this as the integral of f of x dx. The difference now is you'll notice there is no a and there is no b on my integral. My integral is what we call indefinite. It is an indefinite integral. A definite integral is an integral that has an upper and lower bound. An indefinite integral has no bound. If f is an antiderivative of f of x on the interval I, then the most general antiderivative of f of x on the I is capital F of x plus c, where c represents an arbitrary constant. A simple reminder our power rule. So what is the power rule? The reverse power rule says add 1, divide by your new one. So how to find an antiderivative using power rule? You add 1, divide by your new power. Now, instead of plugging in, you're going to add a c. And then what I did is give you all of our basic rules. So the integral of 0 is c. The integral of a constant k is k of x plus c. The integral of k of some function is k, antiderivative of the function. You can integrate functions added together, subtracted together, and then our trig functions. Trig functions are sine becomes negative cosine, cosine becomes sine, secant squared is tan, secant tan is secant, cosecant squared is negative cotan, and cosecant cotan is negative cosecant. Okay, so now what we're going to do is find the antiderivative of our functions. So we're finding them in general. So antiderivative is simply to integrate. You're integrating without bounds. So we would say that capital F of x is equal to, and again, constant stays, add a power, divide by your new power. Constant stays, add to the power, divide by the new power. If it's linear, and then now the new part, a plus c, is the derivative of any constant, goes away. Clean it up. 12 divided by 3 is 4. 6 divided by 2 is 3. We're done. If you have a fraction, my suggestion is always to clean it up, especially when you have a single denominator. So this is really the same as x over x to the 1/2 plus 1 over x to the 1/2. So you can take that denominator, rewrite it under both. Then you do top minus bottom, so 1 minus 1/2 is 1/2. And then we bring this one up as a negative power. So we're going to integrate x to the 1/2 and x to the negative 1/2. So we're going to add 1 to those and then divide by that, which is like multiplying by the reciprocal. So 1/2 plus 1 becomes 3/2. And then multiply by your reciprocal. Negative 1/2 plus 1 becomes 1/2. Its reciprocal would be 2. And now, because we are without bound, plus c. We still don't have a rule for if something is to a power, so we don't have a reverse chain rule yet, which means I need to FOIL this. So you get t to the 4th plus 2t squared plus 1. So my antiderivative becomes 1/5 t to the 5th plus 2/3 t cubed plus t plus c. Okay? The antiderivative of sine is cosine. However, the derivative of cosine became negative sine. So if you integrate sine, you get negative cosine. It's kind of like thinking of that 2 out in front again. So it doesn't mean a whole lot when you antiderive. So you get capital F of x equals negative 2 cosine x plus c. Since c represents an arbitrary number, even though we brought that 2 out in front of our problem, the 2 does not multiply by that c. We never associate any numbers with c. C is always just c. So you don't make it like 2c, you don't make it 1/2 c. C is c. Okay, f of x equals the sine over cosine squared. So you have two choices. We don't really have a rule for sine over cosine squared because we don't have a reverse quotient rule. So what you have to do is kind of think of this as sine x over cosine x times 1 over cosine x. So what is sine over cosine? Well, sine over cosine is tan. 1 over cosine is secant. So this is really the equivalent of tan x secant x. So the antiderivative of tan x secant x is c. Okay. I think mine has a slate paper, right? This should be a 2. All right, so again, same idea. You have to take that single denominator and write it under all of your numerators because we don't have a quotient rule. So this is really the same as 2,600 x to the negative 3 plus 2x, x over x cubed becomes x to the negative 2 plus 0.001 x to the negative 1. That means to integrate, we add 1, so we're doing that reverse power rule. So you get 2,600 x to the negative 2 over negative 2. So 2,600 divided by negative 2 is negative 1,300. And since it would be x to the negative 2, I'm going to drop it down as x squared. Two x to the negative 2. So again, add 1 to that power, you get negative 1. So that makes us negative 2 over x. And the last one, if you started to do your reverse power rule, you get negative 1 plus 1, which gives you x to the 0. So you need to remember that if you get x to the 0, that's not the power rule, that is a natural log. So you get plus 0.001 ln x plus c. And then last but not least, if you have 1 over x, we know that that is our ln. ln is always with the absolute values. And we're out. Our e to the x rule is still e to the x, but now we have a plus c. So if you integrate e to the x, it becomes e to the x plus c. 1 over x becomes ln. And then next week, we're going to talk about what if it's not just e to the x, etc. And then the one that maybe we haven't hit on or talked about is if you integrate 1 over ln a to the x plus c. So it's like our e to the x rule, but with 1 over ln a, because 1 over ln e became 1, so we never saw it. Okay, so the 3 is just a constant. A constant out in front does not affect my problem. So the antiderivative of 3e to the x becomes capital F of x equals 3e to the x plus c. F of x equals 6x becomes capital F of x equals 1 over ln 6 times 6 to the x plus c. And then finally, the part where we get to figure out how does c matter, what does c mean? Well, there are ways in which you can solve for c. So in the fundamental theorem of calculus, we talked about the initial, final, and then the area between them. So this is very similar, but what we can do is take given conditions. So f of 1 equaling 2 is a condition for f, which is what we are trying to find. We are given that the derivative is x root x. So I'm going to think of f prime as x times x to the 1/2, which is really like x to the 3/2. And the reason I want to do that is x to the 3/2 is a lot easier to integrate than x root x. So again, it comes into play like, do you know your algebra? So x on the outside is really like x to the 1. Square root of x is x to the 1/2. Two same variables multiplied together says you add their exponents, giving me that 3/2. So what we're going to do is integrate f prime of x dx so that I can find f of x. So in this case, that's like integrating x to the 3/2 dx, which is equivalent to x to the 5/2 2/5 plus c. However, now my answer does not need to stay as plus c. So plus c means that this answer could arbitrarily be anywhere shifted up or down in the universe. But I know that this function f must pass through the point 1, 2. Which means that my function cannot live arbitrarily anywhere in the universe because my function needs to go through this point. So if f of x equals 2/5 x to the 5/2. But that same f of x says that f of 1 must equal 2. Then it's fair to say that 2 equals 2/5 1 to the 5/2 plus c. And then I can determine what that c must be. So 1 to the 5/2 is 1. So 2/5 plus c needs to equal 2. So c needs to equal 10/5 minus 2/5 or 8/5. So what that means is that this function not only goes through 1, 2, but it also now has a y-intercept of 0, 8/5, that's my c. So it tells me that the graph of 2/5 x to the 5/2 is shifted up 8/5. So it's going to live or go through some point near here to give me that curve. Make sense? F double prime is equal to 12x squared plus 6x minus 4. And then we're given f of 0 and f of 1. So I need to go from f double prime to f. So we're going to integrate f double prime of x dx, which would give me f prime of x, which gives me 12x squared. So you add 1, so you get x cubed. 12 divided by 3 is 4, plus 6x squared over 2 minus 4x plus c. But that is f prime. I need f of x. So I need to integrate again. So now 4x cubed would become 4x to the 4th over 4. 3x squared would become 3x cubed over 3. Negative 4x would become negative 4x squared over 2. So you get negative 2x squared. If you take the antiderivative of a constant, it becomes that constant times x. So this is going to become c sub 1 of x. Again, antiderivative of a constant becomes that constant times x plus c sub 2. Because again, you have to add that arbitrary constant. Now, why did I identify them as C1 and C2? Well, here's the thing. C is a constant. We don't know what it is yet. But C does not have to be the same number for the linear part as it does for the constant part. So I have to label them as C sub 1 and C sub 2 because there could potentially be different numbers. And again, we're going to use those initial conditions to find them. And I want to start with the condition f of 0 before f of 1. Why do I want to start with f of 0 before f of 1? Well, if you think about f of 0, what is that 0 going to do to any term with an x in it? It's going to make it go away. So that means that f of x, if you plug in 0 for x, has to equal 4. Therefore, what do I know about c sub 2? It's equal to 4. So if I know c sub 2, and I have a second initial condition, I can now plug f of 1 in. Instead of c sub 2, I'm going to make it 4, and I can solve for c sub 1. So 1 plus 1 is 2. 2 minus 2 is 0. Subtract 4 over. 1 minus 4 is negative 3. So c sub 1 is negative 3. C sub 2 is 4. Therefore, f of x is x to the 4th plus x cubed minus 2x squared minus 3x plus 4. So again, my final answer for my function has no arbitrary constants. It is a final answer with all numerical values plugged in. All right. So, I feel like every year and every problem in all your math classes, all the way down to algebra 2, they always talk about a ball being thrown. So, a ball is thrown down from a building. So again, standing up on a building, you throw your ball down. I throw it down at a velocity such that at 1 second, it is 76 feet per second. So it's thrown down with a downward velocity such that at 1 second, so what that means is that v of 1 is negative 76. That's what that's saying. Because downward velocity means it's going down. And it is 10 feet above the ground at 2 seconds. So now I have velocity and I have position. So position, we either use s of t or x of t. So s of t for position is like saying s of 2, because t is time, 2 seconds. The ball is 10 feet above the ground. So again, here's my man throwing the ball. We don't know how high up that man is. It says, goodbye ball, you're going down. The height of the ball is at 10 feet, 2 seconds into the ball's path. What is the ball's initial velocity? How tall is the building? So our velocity and stuff is all in terms of feet per second. So in the world of physics and mathematics, if you're in meters per second, gravity is negative 9.8. If you're in feet per second, gravity is, what do I know? Negative 32. So negative 32 feet per second. So the acceleration due to gravity would be negative 32 feet per second squared. So why does that matter? Well, if we want to find velocity, I need to integrate acceleration. So the acceleration due to gravity would be negative 32 feet per second. So velocity would equal the integral of acceleration, which would equal the integral of negative 32 dt. So velocity would be negative 32t plus c. Now you would use your v of 1 is negative 76 to say v of 1 is negative 76, which is negative 32 times 1 plus c. So c, add 32 to the other side. So negative 76 plus 32 would be negative 44. So what that means is that the initial velocity would be negative 44 feet per second, because that's where it was being thrown at time 0. So again, if you found v of 0, you'd get negative 44, because that is that constant that you are doing it at. And then the velocity would continue to increase at negative 32 feet per second due to gravity. So the person threw it at negative 44. Gravity increases that speed, making it faster and faster and faster over time. Also making sense? Okay. So negative 44 is my initial velocity. How tall is the building? So if initial velocity is the y-intercept, the y-intercept of position would be the height of the building, right? Because again, time equal to 0. So how do we find the height of the building? We have to integrate velocity. So position would be equal to the integral of velocity. So negative 32t squared over 2. C is equal to negative 44. So that'd be negative 44t plus my new c value. And again, taking a condition I was given, we say that 10 equals negative 16 t squared minus 40 for t plus c sub 2. But again, instead of all those t's, I'm going to set it equal to 10. And then my t is going to become a 2. So 2 squared is 4. 4 times negative 16 is negative 64. So I have 10 plus 64. So I'm going to add it over. 2 times 44 is 88. Again, negative. So when I move it, it will be positive. So the height of the building is 10 plus 64 plus 88. Or 98 plus 64, which is really like 162. So the height of the building is